Good evening. Okay. Shivam. Shivam.
Sorry, sir. I did my mistake, sir.
Okay, Amma. Okay. Bye. We'll start. Right. So last day we discussed the basics of Nyquist plots. So today we'll draw the Nyquist plot. When the system is stable, I told in the last day, whenever n equal to p, then the system is stable. What is n? What is n? N is nothing but number of encirclements about the critical point. P is nothing but open loop transfer function poles in the right of S-plane. Poles of characteristic equation, which are nothing but open loop transfer function poles in the what? Right of the S-plane. Then the system is stable. Up to that we discussed. And we discussed even pole zero configuration and principle of argument. What is the principle of argument concept? If there are the p poles, z zeros are enclosed by the random selected closed path, like this random selected closed path. For example, I taken 0, pole, then randomly selected one closed path. So then what happened? The corresponding g of s, h of s plane. This is S plane. The corresponding g of s, h of s plane encircles the origin with p minus z times. Encircles the origin with p minus z times, I told. So encircles the origin n equal to what? P minus z. This is the principle of argument I told. But here, one concept is that this random selected closed path should not pass through any pole or zero. Why it should not pass through any pole or zero means, as I selected a transfer function like gh equal to s plus 1 by, the last class I selected s plus 2, s plus 3. This is the transfer function I selected. S plus 1 by s plus 2, s plus 3 I selected. So here, the random selected closed path should not pass through any pole or zero. That means Nyquist contour should not pass through any pole or zero. Why it should not pass through any pole or zero means, in case it is passes through pole, what happen? One of the point become -2. If substitute here -2, s equal to -2, then it become infinity. So infinity means what happen here? And not only that, for example, it passes through exactly G2, the point here infinity. Next point become finite. We cannot join infinite point with what? Finite point. At -2, infinity. Next point, finite. We cannot join infinite point with what? Finite point. Infinite join. But infinite point, finite point should not join. That's why random selected closed path should not pass through any pole or any zero. Even it should not pass through zero also. What happens if it passes through zero? Tell here. In case it passes through -1, if I substitute -1, it will become 0. If it becomes 0, if you draw the plot, then the plot passes through 0 like this. The plot passes through 0. It is passing through 0. Then we cannot identify. You may get like this, you may get like this. Whatever it is, that should be passes through 0. Then you will get a doubt that either that point is encircled origin or not. That is the problem. That's why the random selected closed path should not pass through any pole or zero. Be remember that. So the random selected closed path, that means indirectly Nyquist contour you can say. The random selected closed path, random selected closed path, should not pass through any pole or zero. Should not pass through any pole or zero. The random selected closed path should not pass through any pole or zero. It should not pass through any pole. It should not pass through any zero. That's all. That means indirectly what you are telling, Nyquist contour should not pass through any pole or zero. Nyquist contour should not pass through any pole or zero. It should not pass through any pole or zero. Be remember this. ठीक है ना, Nyquist plot should not pass through any pole or zero. That's all. ठीक है. Next. Now, note down one problem. Draw the Nyquist plot and discuss the stability. Draw the Nyquist plot and discuss the stability. For G of S, H of S equal to 1 by S into S plus 1. 1 by S into S plus 1. ठीक है ना? Come on, do it. Come on, do it. First, draw the Nyquist contour. Next page. So, what is the problem we selected? G of S, H of S equal to 1 by S into S plus 1. Now, come on. Draw the Nyquist contour. Nyquist contour, you draw it. First problem, I'll go by standard procedure. After that, we'll go by shortcut. One pole at origin, one pole at -1. Then draw the Nyquist contour. It is not writing. Okay. So this is the Nyquist contour. This is the infinite radius semicircle. What is the direction we selected? Clockwise. So like this. This is minus j infinity. This is plus j infinity. Nyquist contour should not pass through any polar zero. That's why we bypass through the what? Right side. We bypass through the right side. This is plus j0. This is minus j0 with small radius bypassed. This is called Nyquist contour. This is called Nyquist contour. Nyquist contour. This is called Nyquist contour. Right. So now we have to divide into sections. Divide into sections. This is section 1. This is section 2. This is section 3. This is section 4. So divide into sections. There are 4 sections. Section 1, section 2, section 3, section 4. 4 sections. So we have to divide. We divided into sections means the polar plot for the straight lines are different. The polar plot for semicircles are different. The procedure of drawing a polar plot with straight line is different. This semicircle is different. So that's why we have to divide into different sections. Different sections. We learned the polar plot. We learn how to draw polar plot for the straight line only in the last chapter. That is from 0 to infinity. How to draw a polar plot for 0 to infinity, we learn it. That is a straight line. So second section, we don't know. Third section, straight line we know. Fourth section, we don't know. So how to draw the polar plots, we'll discuss. Now we select the section 1. So put the heading section 1. So section 1. What is the frequency range for section 1? 0 to infinity. Omega equal to 0 plus 0 to plus infinity. Omega plus 0 to plus infinity. Omega is plus 0 to plus infinity. Plus 0 to plus infinity. Now S replaced by j omega. S replaced by j omega. So come on, write the magnitude. S replaced by j omega. So GH of j omega equal to 1 by j omega plus 1. Then magnitude 1 by omega root of omega square plus 1. Write the phase angle. Minus 90 minus tan inverse of omega. Minus tan inverse of omega. So now come on, draw the polar plot. What is the direction? Clockwise. We can say your direction is clockwise. So omega 0. What is the magnitude? Infinity. What is the phase angle? Minus 90. Omega infinity. What is the magnitude? 0. What is the phase angle? Minus 180. Direction same. So that's all. So satisfied our condition. Now draw the polar plot. Come on. You draw the polar plot. Draw the polar plot. Come on. Draw the polar plot. Where it starts? Minus 90. Where it ends? Minus 180. Minus 180. Minus 90 minus 180. So it starts with infinite magnitude, means parallel to minus 90. Already we drawn in the last class. And moves close to minus 180 and then become 0. This is the polar plot. Magnitude is infinity, omega 0 plus. This is the polar plot for what? Section 1. It is section 1. It is actual polar plot. It is a polar plot. It is a polar plot. Okay, na? This is a polar plot for section 1. Here omega is what? Plus infinity. Magnitude is 0. Magnitude 0. So we are drawing from 0 plus to plus infinity. This is the polar plot. This is the polar plot. ठीक है ना? Next, go for section 2. This is for section 1. Next, go for section 2. Section 2. This is for section 1. Next, section 2. Section 2. What is the frequency range? Tell for section 2. Omega is 0 minus to 0 plus. Omega is 0 minus to 0 plus. Check it. 0 minus to 0 plus. Omega is 0 minus to 0 plus. So 0 minus to 0 plus is the section 2. Okay, na? Now draw the plot for this. What is section 2? It is a small radius semicircle. It is a small radius semicircle between the angle of what? Between the what is the angle? Between the angle of what? Come on. Between the angle of, this is the angle of what? Minus 90. This is the angle of what? Plus 90. That means what is section 2? Minus 90 to plus 90. Minus 90 to plus 90. Yes or no? Section 2 is a small radius semicircle between the angle of minus 90 to plus 90. Section 2, it is a small radius semicircle. Small radius semicircle. Between minus 90 to plus 90 degrees. Plus 90 degrees. That means it is having a what? Radius is there, angle is there. That's why. Hence, S is replaced by, as it is having radius and angle, hence S is replaced by, hence S is replaced by epsilon e power j theta. Epsilon e power j theta. Where epsilon tends to 0, and theta tends to minus 90 to plus 90. Theta tends to minus 90 to plus 90. Minus 90 to plus 90. Theta tends to minus 90 to plus 90. Okay. Nyquist plot should pass through right only. Yeah, what man? Where it is passing? It passes through right only. What is your doubt? Nyquist plot should passes through. It should be selected in the right side only. Nyquist contour should not pass through right. Who told, man? Nyquist plot pass through right only. Right, that's all. Come on, right. So theta tends to minus 90 to plus 90. That's all. So next, come on, draw the plot. So what you have to do? Replace GH of S. S is replaced by what? Epsilon e power j theta. Epsilon e power j theta. Limit. So here what happened? S replaced by epsilon e power j theta. That equal to limit epsilon tends to 0. Theta tends to minus 90 to plus 90. Minus 90 to plus 90. Theta tends to minus 90 to plus 90. That equal to what? 1 by epsilon e power j theta. Wherever S is there, they replace epsilon e power j theta. Epsilon e power j theta plus 1. Plus 1. That's all. So now substitute epsilon tends to 0 and theta minus 90 to plus 90. As epsilon is very, very small, then what happened? I can replace here epsilon tends to 0. So that I can compare with 1. I can neglect this term. So by comparing 1, by epsilon 0 we can neglect. But don't substitute here epsilon 0 because 1 by 0 become infinity. Here to neglect by comparing 1, so that we can neglect this. That's why I substituted epsilon equal to 0. Now what I can write this? Tell what I can write. Limit epsilon tends to 0. Epsilon tends to 0. Theta tends to same minus 90 to plus 90. What I can write? 1 by epsilon e power j theta. 1 by epsilon e power j theta. That equal to limit epsilon tends to 0, theta tends to same, theta tends to same. What I can write? We have to write the magnitude and phase. We have to write the magnitude and phase. Then you have to draw the polar plot. So magnitude and phase. So this can be written as 1 by epsilon e power, what I can write? J minus theta, because j theta power minus 1 you can write now. So j minus theta. Yes or no? We can write j e power j theta. Whole power what? Minus 1 you can write. Whole power minus 1. So e power j theta minus 1 means e power j minus theta. We can write e power j minus theta. Minus theta. Now tell what is the magnitude here? What is the magnitude? What is the phase here? Come on, write the magnitude, write the phase. What is the magnitude? So what is the magnitude for? Epsilon tends to 0, theta tends to same. What is the magnitude? So magnitude of 1 means 1 only. So 1 by epsilon magnitude, epsilon only. E power j theta magnitude 1. E power j theta magnitude is what? 1. E power j minus cos theta plus or minus j sin theta. Na? So its magnitude is 1. What is the phase angle? Angle of 1, 0, angle of epsilon 0, angle of e power j minus theta is minus theta. Angle is minus theta. E power j minus theta angle is minus theta. That's all. So this is the magnitude, this is the phase angle. Now draw the polar plot. See section 2. What is the section 2? Small radius semicircle. So take the small radius semicircle. Come on. Very small radius semicircle. Section 2 only I am drawing here. So this is, for example, section 2. This is the part of the Nyquist contour. In the Nyquist contour, I am taking only section 2. Only section 2. Okay, na? This is section 2. So here what I taken? Minus J0. Here what I taken? Plus J0. This is the direction. This I taken for section 2. This is the section 2. Now this section 2 I divide into different points, different angles I consider. This is point 1, for example. I'll take, what is the angle here? Minus 90. Now we'll divide into different angle. This is second point, for example. What is the angle? Minus 45. For example, this is the third point. What is the angle? Tell 0 degrees. This is the fourth point. What is the angle? Tell plus 45 degrees. This is the fifth point. What is the angle? Tell plus 90. Now I divided this section 2, small radius semicircle. I divided into what? 5 parts, because I have to find the magnitude and phase. Now come on, find the magnitude and phase. So how to find? Epsilon tends to 0, that is fixed. And then theta. Theta is varies. Theta varies. So theta, here theta, magnitude and phase. Theta, magnitude and phase. Fill this tabular form. Come on, do it. First point, bolo. First angle is what? Minus 90. Minus 90. So second angle is what? Minus 45. Minus 45. Third angle is what? 0. Third angle is 0. Fourth angle is what? Plus 45. Fifth angle is what? Plus 90. Fifth angle plus 90. Come on, magnitude 1 by epsilon. Epsilon 0 means magnitude infinity only. For all the angles, magnitude is infinity only. Just infinity. Infinity. Now tell. Come on, angle bolo. What is the angle? Substitute minus 90. Minus minus become plus 90. Minus here minus minus again become what? Plus 45. Plus 45. 0 means 0. Then plus 45 means substitute here plus 45, it will become minus 45. Next is substitute here plus 90, it will become minus 90. So now draw the plot. Tell. You draw the plot. Draw the polar plot. Draw the polar plot. Come on. So what is the first point? Tell. Plus 90 infinity. So this is plus 90 magnitude of infinity. That means this is the point 1. I consider this is magnitude infinity. This is the first point. So plus 1 magnitude of infinity. Magnitude of infinity. Next, bolo. Right. Second point. Second point is what? Tell? Plus 45 degrees. 45 degrees. So along 45 degrees, for example, what is the angle? Tell? 45 degrees. Next one is what? Plus 45. I'll draw a line of plus 45, for example. This is plus 45 degrees. Plus 45 degrees. This is the second. So plus 45, what is the magnitude? Infinity. For example, I'll select this is the second point. Magnitude is infinity. Third point is what? 0 degrees, magnitude infinity. 0 degrees. I'll select here. Magnitude is infinity. This is the what? Third point. Fourth point is what? Minus 45. Minus 45. Along which magnitude of what? Infinity. Magnitude of infinity. Magnitude infinity. Next, fifth point is what? Minus 90. Magnitude of infinity. Magnitude of infinity. This is the fifth point. Magnitude of infinity. Now draw the plot. Now draw the plot. Join all the points, then it will become the answer. So now join all the points, then it will become the polar plot. Come on, join it. Join it. 1 to 2, 2 to 3. Come on, join. First 1 to 2, 2. 1 to 2, 2 to 3, 2 to 3, 3 to 4, 4 to 5, 3 to 4, 4 to 5. So, this is the polar plot. 1 to 2, give the direction. This is the polar plot. 2 to 3, give the direction. 3 to 4, give the direction. 4 to 5. So this is called the polar plot for section 2. What we got here? Infinite radius semicircle. This is called, what is the radius? Infinity, na? Here to here infinity. So I can say infinite radius semi means 180 degree circle. This is called infinite radius semicircle. Semi means 180 degree circle. Infinite radius semicircle. But each and every problem we cannot solve like this, na? For each and every problem we cannot solve like this. We cannot solve like this. Na? You should not, each and every problem we cannot draw like this. Okay? So that's why I want to give one conclusion. I'll take one example for the conclusion. Okay? Right. Next one. Example. I'll take one small example. Example for conclusion. Example for conclusion. This is just example for conclusion. I'll give one small conclusion so that directly we can draw the polar plot. I'll take g of s h of s equal to 1 by s cube. 1 by s cube. Why? Because section 2 completely belongs to the poles and zeros at origin, especially poles at origin. Section 2 belongs to the poles at origin. So that's why I'll take 1 by s cube. Gh equal to 1 by s cube I'll consider. Now s replaced by replace s by 3 poles at origin. Now what I selected 3 poles at origin. That means if I represent 3 poles at origin, then small radius semicircle. I already told random selected closed path or Nyquist contour should not pass through the what? Any pole or zero. Today first starting that only I told. So right here what happened? So 3 poles at origin. 3 poles at origin is there. If you draw the Nyquist contour, it should not pass through that. It should be bypassed like this. It should be bypassed like this. Like this, you have to draw the Nyquist contour. You have to draw the Nyquist contour like this. Okay, na? So that's why replace s by bolo same thing. Replace s by epsilon e power j theta. Replace s by epsilon e power j theta. Same thing. And why? This is what? Minus j0. Same thing. If 1000 poles represent at origin also, 1000 poles represent at origin also. The section 2 is same. This section 2 is same. This is section 2 na. This is section 2. This is section 2. The section 2 is not going to be changed. Even 1000 poles represented at origin. That's why S should be replaced by e power j theta, and epsilon tends to 0. Theta tends to what? Minus 90 to plus 90 only. That is not going to be changed. That is not going to be changed. Come on, now do it. GH of epsilon e power j theta. Epsilon e power j theta. That equal to limit epsilon tends to 0. Theta tends to minus 90 to plus 90 only. Minus 90 to plus 90. Then what I can write? 1 by epsilon e power j theta whole cube. Whole cube. Epsilon e power j theta whole cube. Okay. This can be written as limit epsilon tends to 0. Theta tends to same. What I can write? 1 by epsilon cube and e power, what I can write? J 3 theta. J 3 theta we can write. J 3 theta. This can be written as limit epsilon tends to 0. Theta tends to same. I can write 1 by epsilon cube. Epsilon cube e power j minus 3 theta. E power j minus 3 theta. E power j minus 3 theta. That equal to limit epsilon tends to 0. Theta tends to same. Theta tends to same. What I can write? What is the magnitude? Tell. 1 by epsilon cube is the magnitude. What is the angle? Tell. Angle is minus 3 theta. Angle is minus 3 theta. Angle is minus 3 theta. Now come on, section 2. Divide this into 4. Same thing. Divide section 2 into what? 5 parts. This is section 2 na. This is section 2. Minus 90. This is the first point. I'll take this the second point. Minus 45. This is the third point. I'll take 0 degrees. This is the fourth point. Plus 45 degrees. This is the fifth point. This is plus 90 degrees. Plus 90 degrees. Okay, na? So divide into 5 parts. Now do it. Come on. Come on, do it. So epsilon tends to 0. Theta. Magnitude. Phase. First point is what? Minus 90. Second point, minus 45. Third point, 0 degrees. Fourth point, plus 45. Fifth point, plus 90. Come on. Magnitude how much here? Magnitude infinity only. 1 by epsilon cube. Epsilon 0 means infinity. 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 Angle bolo. What is the angle? Minus 90 substitute here. Minus of minus 90 means plus 270. Plus 270. Here how much? Tell. Plus 135. Just a substitute. Minus 45 here. Minus 45 into minus 3. Plus 135. So 0 means 0. Here minus 135. Here minus 270. Now draw the plot. You draw the plot. Come on, draw the plot. This is not required. Right. So we'll draw a little bit up also, so that we require space. Right. First represent plus 270. Where is plus 270? This is plus 270, na? Plus 270. This is plus 270. On which magnitude is infinity. So plus 270. This is the first point. This is the first point. This is the first point. Magnitude infinity. Magnitude infinity. Second point, plus 135. I'll draw a line of plus 135. Plus 135 like this. For example, this is plus 135 degrees. On which a magnitude of what? On which the magnitude is? This is second point, magnitude infinity. Magnitude infinity. Third point is 0 degrees. 0 degrees. On which magnitude is what? Infinity. Magnitude infinity. Third point. Fourth point is what? What is the fourth point? Minus 135. They like this. Minus 135 degrees. On which the magnitude is infinity. This is the fourth point. On which magnitude is infinity. Next, fifth point is what? Plus 90. This is plus 90. Fifth point is minus 270. Minus 270. This is minus 270 only, na? Minus 270. On which magnitude is infinity. This is the fifth point, magnitude infinity. Now come on, join 1 to 2, 2 to 3, 3 to 4. Come on, join it. 1 to 2, 1 to 2. 1 to 2. Next 2 to 3. 2 to 3. Next 3 to 4. Next 4 to 5. So like this you have to draw. This is the third point, magnitude infinity. The second point, magnitude infinity. Like this. So 1 to 2, 2 to 3, 3 to 4, 4 to 5. So 1 to 2, give the direction. 1 to 2. Next 2 to 3, give the direction. 3 to 4, give the direction. 4 to 5, give the direction. This is the what? Polar plot for 3 poles at origin. 3 poles at origin. So what we got here, tell? We got how many 180 degree circles we got? Year to year 180, year to year another 180, year to year another 180. That means 3 180s we got. Check it, year to year 180, year to year second 180, year to year another 180. One pole at origin gives the 180 degree circle. For example, see here, one pole here, only one pole at origin, 1 by S na, check it. 1 by S, one pole at origin. One pole at origin given what? 180. Minus 92 plus 90, what is the angle? Tell. Minus 92 plus 90, total angle. Angle from minus 90 to plus 90. What is the total angle? 180 degrees. So 180 degrees. One pole at origin, 180 degree circle. One pole at origin, 180 degree semicircle. Here 3 poles at origin, 3 180 degrees. Here to here 1, here to here 1, here to R. Minus 272 plus 270. What is the angle? Tell. 540 degrees. 540 degrees. Just add it. 270, 270. How much? 540 degrees. 540 degrees means how many times of 180 degrees? Tell. 180 degrees into 3. 3 times of 180 degrees. 3 times of 180 degrees. 540 degrees means 3 times of 180 degrees. 3 times of 180 degrees. That means simple conclusion is the number of infinite radius semicircle equal to number of poles at origin. Number of infinite radius semi means 180 degree circles equal to number of poles at origin. Number of infinite radius semicircles equal to number of poles at origin. Number of infinite radius semicircle equal to number of poles at origin. Okay. Right. Okay, na? So this is the conclusion. Number of infinite radius semicircles equal to number of poles at origin. Okay, na? One more thing. But if in case zeros are exist at origin, in case zeros are exist in the origin, then this statement not valid. This is valid for only poles at origin. For zeros, it is not valid. First of all, zeros, it won't give the infinite radius semicircle. Even if it gives also, go by standard procedure. Like this standard procedure you go. For example, say I'll take s by s plus 1, for example. I'll take a 0. Epsilon 0 means what is the magnitude you will get tell? Epsilon 0 means S0 na. What I can write? Epsilon e power j theta by epsilon e power j theta plus 1 means epsilon 0 means it will become 0 only. It will become 0 only. Even r infinity, infinite radius you take also, it will become 1 only. Generally, we don't consider first of all zeros at origin. Poles at origin only consider. So be remember, this statement valid for only poles at origin. This statement valid for only poles at origin. Be remember this. Number of infinite radius semicircles equal to number of poles at origin. This statement very, very important. Next, go for section 3. Okay. Right. Direction clockwise only. Now, always direction clockwise only. Right. Next. Next one. Next, section 3. Section 3. What is section 3? Tell. Section 3. What is section 3? Nyquist contour minus infinity to 0. Section 3 is minus infinity to 0. Minus infinity to 0. Section 3 is omega equal to minus infinity to 0. It is simply 0 minus 0. It is simply what? Mirror image of section 1. Section 3 is because same length, na? Same length. Section 1 length, section 3 length, same. It is a mirror image, just it is a mirror image of section 1 with respect to real axis. With respect to real axis. Section 3 is mirror image of section 1. Section 3, it is a mirror image of section 1. Mirror image of section 1. About real axis. About real axis. Section 3, it is a mirror image of section 1 about real axis. About real axis. So, but the direction is continuous. But the direction is continuous. Don't change the direction. Mirror image means direction changes. No, don't change the direction. But the direction is continuous. But the direction is continuous. But the direction is continuous. Come on, do it. Come on. Section 1, how we drawn? Ek baar dekho. This is the section 1. Mirror image means you'll get above like this. You'll get above like this. So that means what is the section 1 we got? Actually not required to draw section 1, but still I'll draw, no problem. So this is the section 1 na. This is section 1. Now draw for section 3. Mirror image you draw. Mirror image with respect to what? Real axis. Simply fold with respect to real axis. Whatever you are getting, that is called the what? Mirror image. Fold. How will get? Same thing you'll get like this. right. Give the direction. This is plus 90. Here what is omega tell? Plus infinity. This is plus infinity, na? Here omega tell minus infinity. Here omega tell minus 0. So this is the mirror image of section 1. Mirror image should be taken with respect to real axis. Don't take with imaginary. Mirror image of section 1. And direction should be continuous. What is the direction? Upward. So same continuous direction should be there. Direction should be continuous. That's all. Next, section 4. Next, section 4. Section 4 you have to do. Come on, section 4. Section 4. What is section 4? Tell. What is section 4? Always with real axis only. Always with real axis only. Okay. Next, section 4. Come on. Section 4. What is the section 4? Tell. Plus infinity to minus infinity. This is the section 4. Plus infinity to minus infinity. Infinite radius semicircle. Section 4 omega is what? Plus infinity to minus infinity. So semicircle. That means what you have to do? Infinite radius semicircle. It is infinite radius semicircle. Infinite radius semicircle. Between semicircle between plus 90 to minus 90. Between plus 90 to minus. Come on, draw it. Draw the plot between plus 90 to minus 90. That means S replaced by, hence S replaced by, hence S replaced by R e power j theta. S replaced by R e power j theta. R e power j theta. Where R tends to infinity and theta tends to plus 90 to minus 90. Theta tends to plus 90 to minus 90. Come on, draw it. Where R tends to infinity, theta tends to plus 90 to minus 90. Okay, na? So now come on, GH of R e power j theta equal to limit R tends to infinity, theta tends to plus 90 to minus 90. Then what you are getting? 1 by R e power j theta, R e power j theta plus 1. R tends to infinity means 1 is neglected. R infinity, by comparing this, infinity means 1 is neglected. Then what we are getting? Tell. Limit R tends to infinity, theta tends to what? Same. Then what we are getting? 1 by R square e power j theta whole square. So this can be written as limit R tends to infinity, theta tends to same, then simply 1 by R square e power, what I can write? E power j minus 2 theta we can write. Then write the magnitude and phase. Limit R tends to infinity, theta tends to same. Then what I can write? 1 by R square is magnitude and angle is minus 2 theta. Whatever it is, R infinity means it become magnitude 0. Magnitude 0 means it is a point at origin. Magnitude 0 means it is a point at origin. That's all. Magnitude 0 means it is a point at origin. Magnitude 0 means it is a point at origin. Magnitude 0 means it is a point at origin. Magnitude 0 means it is a point at origin. Means it is a point at origin. It is a point at origin. It is a point at origin. Magnitude 0 means it is a point at origin. It is a point at origin. ठीक है ना? Local author books, some books what they did, not all the books, some books what they did, this magnitude 0, they consider a small circle and then they are drawing the what? Small radius semicircle, but don't do that. And they'll draw like this. Small circle around this, you'll get, for example, like this. Like this, they'll draw. Like this, they'll draw. Small radius circle, they'll draw. So that means plot will be like this, they'll do. This is the polar plot. So they'll join polar plot to this small radius semicircle. Small radius semicircle. Again, mirror image means like this, they'll draw. Like this, they'll draw. And this will become a Nyquist plot. So whenever like the small circles, if we see around the 0, make it dark there, that's all. Or join to origin. Make it dark, join to origin. Because that small radius circle never affect the what? Stability. That small radius circle not affecting the stability. But till now in the competitive exam, even you check from before your date of birth, last 30-40 years paper, there is no single question like taking a small radius circles at the what? Around the origin. That's why simply you follow a standard books. If you see the standard books, simply they select the what? Point at origin. They'll select the point at origin. You also, section 4, simply select section 4. Simply you say magnitude 0. Magnitude 0 means it is a point at origin. That's all. Simply neglect the section 4. Don't consider. So this is the completion of all the 4 sections. Now join all the 4 sections, then it will become a Nyquist plot. Now join all the 4 sections, then it will become a Nyquist plot. Come on, join it. Come on. Join all the 4 sections. Join all the 4 sections, then you will get the Nyquist plot. The Nyquist plot is nothing but combination of polar plots only. Come on, draw it. Draw it. First section 1, where it started minus 90. Like this. Ooh. Clockwise. This is section 1. This is called polar plot. First, always draw the polar plot. Next, take the mirror image. Second step, 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 take the mirror image. This is the mirror image. So join it, no problem. Next, listen. Section 3. This is what? Mirror image. This is what? Section 2. This is section 3. Mirror image. First polar plot. Next, immediately draw the mirror image. Then after that, join the section 2. Section 2 you join. What is section 2? Infinite radius semicircle. What is this frequency? Tell omega 0 minus. This is what? Listen. This is omega 0 plus magnitude of infinity. This point is magnitude of infinity. Omega 0 plus magnitude of infinity. Magnitude of infinity. Magnitude of infinity. What is this tell? What is here? Frequency you tell. This frequency is minus 0. Minus 0. And magnitude of what? Infinity. Magnitude of infinity. Now join minus 0 to plus 0. Where is section 2? Section 2 is, this is section 2. What is the frequency here? Minus 0. That means here omega is what? Here omega is minus 0. Here omega is what? Plus 0. Here omega is plus 0. Therefore, minus 0 to plus 0. So that means at minus 0, magnitude infinity plus 90. So therefore here at omega minus 0, magnitude infinity, what is the angle here? Plus 90. Plus 90. Plus 90. And check it here. Omega plus 0 minus 90 plus infinity. Minus 90 plus infinity. And the end at what? Minus 90 plus infinity. Start at what? Plus 90 infinity. Start at plus 90 infinity. Start here. Plus 90 infinity. End minus 90 infinity. End here. That means be remember the infinite radius semicircle always. Infinite radius semicircle always. Start at where the mirror image end. It should be. It is valid for all the problems. Start at where the mirror image end and move in clockwise direction. And move in clockwise direction. End where the polar plot is started. 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 The infinite radius semicircle. The infinite radius semicircle starts at where mirror image end. Where mirror image is end. And the infinite radius semicircle start where the mirror image end. And infinite radius semicircle and infinite radius semicircle end at where the polar plot started. Where polar plot started. Polar plot starting should be ending point. Mirror image is a starting point. Where polar plot end. Where the polar plot end. So the infinite radius semicircle start where the mirror image is end, and infinite radius semicircle end where the polar plot is start. Where the polar plot start. Where the polar plot start. Where the polar plot start. ठीक है ना? And infinite radius semicircle direction always clockwise only. Infinite radius, blindly draw clockwise. Infinite radius semicircle direction is always clockwise. Direction is always clockwise because it depends on section 2. Because it depends on Nyquist contour. It depends on Nyquist contour of section 2. Nyquist contour of section 2. Section 2. As section 2 bypass through the right. Section 2 where it is bypassing through the right, na? As it bypassed through the right, infinite radius semicircle direction should be clockwise. As section 2 bypassed through the right, as section 2 bypassed through the right, infinite radius semicircle is clockwise. Infinite radius semicircle is clockwise. Semicircle direction is clockwise. Always blindly draw the clockwise. For object it is more than sufficient. Don't draw anti-clockwise because default direction of Nyquist contour is clockwise only. That's why This infinite radius semicircle direction, always draw the clockwise only. Okay, na? Now go for the stability. How to find the stability? What is the transfer function? Tell. What is the transfer function? G of s, h of s equal to what is the transfer function? 1 by s into s plus 1. When the system is stable, tell n equal to p, system is stable. N equal to p, system is stable. N equal to p, system is stable. N equal to p, closed loop system stable. What is n? Tell. Number of n circle means about -1. What is p? Tell. Open loop transfer function means gh poles in the right hand side. How many gh poles right? Open loop poles right. How many? Tell. Open loop poles right. Here right side how many poles? No open loop poles right. How many? No open loop poles right. That means p equal to 0. Open loop poles right side is 0. That means p equal to 0. Now take a critical point. Critical point means -1 plus j0. Draw a line. How many times? Draw a line like this. You draw it. You draw it 90 degrees like this also, nothing wrong. Draw a line. How many times this plot encircled this -1? How many times the Nyquist plot encircled -1? 0. It is not at all encircled. N is 0. P also 0. P also 0. N also 0. That means N equal to P. Then closed loop system is stable. N equal to P. Then closed loop system is stable. N equal to P. Closed loop system is stable. That's all. Okay. Okay. It is GH real, GH imaginary. Already I told now this is real of GH. This is what? Imaginary of GH. It is a GH plane. That's all. It is a real GH. It is imaginary GH. Next, come on. Next, now onwards, what you do? Draw the polar plot, take the mirror image. Then automatically you will get the answer. Okay, na? Draw the polar plot, take the mirror image. Yes, polar plot also GH plane only. Right. Even Bodo plot also GH plane only. What we are taking? Magnitude of GH or not? Phase of GH. Everything all are GH only, na? Right. Next. Poles and zeros are represented in the S plane. The plot is we are mapping from S to GH. That's all. Next, draw the plot. Come on. Draw the plot. Draw the Nyquist plot 10 by S plus 1. Do it. 10 by S plus 1. Root locus S plane, no doubt. Because poles and zeros representing me, that is S plane. Poles and zeros we are representing, that is S plane. Right, come on. Do it. S replaced by J omega. Draw Nyquist plot and find stability. Draw Nyquist plot and find stability. S replaced by J omega. GH of J omega equal to 10 by J omega plus 1. Then find the magnitude. 10 by root of omega square plus 1. Phase angle minus tan inverse omega. Angle of 10 is 0. Angle of 10 is 0. So simply minus tan inverse omega. What is the direction? Clockwise. Come on, draw the plot. Omega 0. Magnitude is 10. Angle is 0 degrees. Omega infinity. Magnitude 0. Angle is minus 90. So select magnitude satisfied. It is satisfied the condition. Now draw the plot. Draw the plot. So it started at where? 0 degrees. Magnitude of 10. Omega equal to 0. Where it end? Minus 90. Magnitude of 0. This is the magnitude 0. So here magnitude 0. Omega infinity. What is the direction? Clockwise. Move in a clockwise direction. End at what? Minus 90. End at minus 90. Direction clockwise. Now take the mirror image. Here take the mirror image with respect to real axis. Means same thing you will get above. Mirror image. Fold with respect to real axis. This is the red color is mirror image. Blue color is polar plot. So this is the mirror image. That's all. It is an Nyquist plot. This is a Nyquist plot. So there is no poles or zeros at origin. No zeros or no poles at origin. That means no infinite radius semicircle. No pole at origin. No infinite radius semicircle. No infinite radius semicircle. Now critical point below -1 plus j0. So n equal to what? 0. P equal to what? 0. N equal to P. Closed loop distance stable. P is called open loop poles right. How many open loop poles right here? 0 na? Open loop poles right. Open loop poles right. That is P equal to 0. So P0, N0, closed loop distance stable. That's all. Next problem. Draw the Nyquist plot. Ten by S plus 1, S plus 2. Come on, do it. Sri Charan, fast. What is the doubt?
Sir, in section 2 diagram, sir.
Already be drawn, na? Tell, what is the doubt?
Section 2, that
This
Not-
only.
3 encirclements will there, no, sir.
Tell.
Sir, here both are infinite, sir. No, sir, they're not intersect, sir.
What?
In the second encirclement, it will not intersect the.
If intersect, how can I identify total angle? If I draw the same path like this, how can I identify total angle? 1000 times I'll repeat. Can I identify angle?
No, sir.
That's why you have to draw the different paths.
Okay, okay.
To identify the angle, we have to draw the different paths. Okay?
Okay, sir.
Okay. Venkatesh, fast. What is the doubt?
Sir, first next. Sir,
Voice
5
is not clear.
Sir, 10 by S plus 1 problem sir. 10 by S plus 1.
Tell.
Sir, ఇందులో డైరెక్షన్ ఇది ఇక్కడ క్లాక్ వైజ్ అండ్ యాంటీ క్లాక్ వైజ్.
What is there? I already told in the polar plot now, negative tan. What is the direction?
క్లాక్ వైజ్.
That's all.
సార్ ఇక్కడ ఈ నైక్విస్ట్ ప్లాట్ లో డైరెక్షన్ ఇటు ఉంటుంది ఇక్కడ రెడ్ కలర్.
Continuous path. Continuous to the what? Polar plot. That's all. This direction continuous.
ఓకే సార్, ఓకే సార్.
Nyquist plot is a closed path. Okay? Right, next. Come on, solve it. Next problem. Do this. S replaced by j omega. Jaldi. Come on, do it, all of you. GH of j omega equal to 10 by j omega plus 1. J omega plus 2. Today we have to close this chapter. Magnitude 10 by root of omega square plus 1. Root of omega square plus 4. Phase angle minus tan inverse omega minus tan inverse omega by 2. What is the direction? Clockwise. Come on, draw it. Omega 0. What is the magnitude omega 0 means? 5. Yes or no? 10 by root 2, root 4 means 5. Angle is 0 degrees. Omega infinity 0. Angle is minus 180. So select the direction. Right. Come on, this is 0 degrees. Magnitude is 5. Omega 0. Magnitude 5. Ending angle minus 180. Magnitude 0. Come on, draw the plot. Start. End at minus 180 na, here na, minus 180 this. Take the mirror image. Take the mirror image. Take the mirror image. This is the mirror image. Now find the stability. Now find the stability. How many poles in the right? Continuous direction. Nyquist plot is a closed path. How many open loop poles right? Open loop poles right is what? P equal to 0. Minus 1 is here. Draw a line. How many times encircle the plot? 0. P also 0. N equal to P. No poles at origin, no infinite radius semicircle. N equal to P. Closed loop distance stable. That's all. N equal to P. Closed loop system is stable. Okay. Next. Draw Nyquist plot. For example, 10 by 10 100 ఏదో s square into s plus 2 into s plus 4. Come on, do it. Abdul.
సార్ మనం ఇందాక ప్రాబ్లం సార్ ఒకసారి ఇందాక ప్రాబ్లం లో అది మనం డైరెక్ట్ మనం ఈ యాంగిల్ ఎందుకు అలా తీసుకున్నారు సార్? డైరెక్ట్ అది 180 డిగ్రీస్ వస్తుంది కదా 0 దగ్గర, మళ్ళీ ఎలా ఎందుకు తీసుకున్నారు సార్?
వాట్ ఎలా వాట్ యాంగిల్, విచ్ యాంగిల్ యు ఆర్ టాకింగ్?
ఇది 0 దగ్గర 180 డిగ్రీస్.
జీరోస్ దగ్గర 180 ఎందుకు ఉంటది? 5 యాంగిల్ ఒమేగా 0 సపోర్ట్ వాట్ ఇస్ యాంగిల్?
0 సపోర్ట్ ఇన్ఫినిటీ. ఒమేగా ఇన్ఫినిటీ 180 డిగ్రీస్ అంటే 0 అవుతుంది. అంటే ఇక్కడే వస్తుంది కదా సార్ డైరెక్ట్.
What you are talking, man? This is starting, this is ending. Omega infinity, what is the magnitude?
0.
Angle?
Minus 180.
Minus 180, 0. This is the point, na?
అంటే అంటే ఇలా ఎందుకు చూస్తున్నారు సార్? అంటే డైరెక్ట్ ఇక్కడ నుంచి తీసుకోవచ్చు కదా ఒమేగా టు ఆ పాయింట్ దగ్గరికి. మళ్ళీ అంటే ఆ
ఇటు
కర్వ్
అటు tell clearly what you are telling. ఇటు అటు అటు ఇటు. క్యా భయ్యా?
బ్లూ కలర్ టర్నింగ్ సార్, టర్నింగ్ ఎందుకు చేశారండి సైడ్
ఆ?
లెఫ్ట్ సైడ్ ఎందుకు ఈ యాంగిల్ ఇలా కర్వ్ ఎందుకు వచ్చింది?
Polar plot studied, then how to draw polar plot? Tell. It's starting point here, ending point here, direction clockwise. How to draw?
కింద నుంచి.
Amal, that's all. What is your doubt?
అది కాదు సార్, అంటే నేను ఇటు సైడ్ వచ్చింది కదా సార్, లెఫ్ట్ సైడ్ ఈ పాయింట్ మనకి ఇక్కడ వరకే ఉండాలి కదా సార్, అంటే 0 to ఇది యాంగిల్.
I didn't get what you are asking clearly. Okay. Left
Sir,
side, left side.
sir.
What left side? -1 you have doubt?
No sir, this
You are
blue
simply
color
wasting
one.
the time.
Blue color plot sir. Blue color one.
You have to draw like this
direct-
only, like this only you have to draw. Because it should be end at -180, means it come close to -180 and then it should be 0.
Okay.
I told very
and-
clearly in the polar plot, again wasting the
Okay.
time.
అదే సార్,
Read
అదొకటే
polar
సార్.
plots,
అంటే
man.
ఎందుకు-
Last day class read. I have to complete this chapter today. That is target. Otherwise, again it is extended. Or ask the doubts at the end. Better I'll discuss the doubts at the end. I don't answer to your questions. At the end I'll answer. Okay? Right. You ask the doubts only at the end. Right. Write the magnitude. S replaced by j omega. GH of j omega equal to 100 by j omega plus 2. Ask the doubts at the end. At the end, I can spend more than 1 hour for doubts. Don't worry. You remember the just page number. Page number, there you want to write what is your doubt. Don't ask in the middle. Even I don't answer also. Right. Magnitude 100 by, because they given dead time for me. I have to complete the syllabus by Friday. But it is difficult only. So possible, I'll ask 1 day extra. Maximum, I'll try to close by Friday. If not possible, then Saturday at least I have to close. Right. Write the phase angle. What is the phase angle? -180 minus tan inverse omega by 2 minus tan inverse omega by 4. Come on, do it. Right. Come on, omega 0. What is the magnitude? Infinity. Substitute omega 0. Magnitude in phase angle -180. Omega infinity 0. Angle is how much? -180, -90, -90, -360. Draw it. Draw the plot. Listen carefully, Bhaiya. Listen carefully, then only can draw. Listen, all of you. Listen carefully. Where it starts? -180. Where it ends? -360. So that means starting here, -180. Starting here, -180. Ending -360. I told it, make it dot at the origin because 0 towards -360 means like this. Then join these two. Which direction? Clockwise. Join in clockwise like this. This is the polar plot. This is the polar plot. Next, take the mirror image. Next, take the mirror image. Mirror image means exactly down. Little bit more length you put it. Why? Because Even though this is infinity, this is also infinity. Mirror image means exact length should be there, but little bit more length you put it. Why? Because you have to draw the infinite radius semicircles. Because two poles at origin means two infinite radius semicircle. Two poles at origin, two infinite radius semicircle I have to draw. So infinite radius, whenever pole at origin, generally starting magnitude is infinity. Poles at origin, generally starting magnitude infinity. So starting magnitude infinity means that infinity point should be joined with infinite radius semicircle. How many infinite radius semicircle here? Two poles at origin, two infinite radius semicircles you have to draw. Two infinite radius semicircles you have to draw. So sometimes they don't give this transfer function. Sometimes they don't give the transfer function. Just they'll give the polar plot like this. Sometimes what they'll do, the Nyquist plot over the frequency range 0 to infinity is shown in figure. The Nyquist plot over frequency range from 0 to infinity, is shown in figure. Then the closed loop system is, they will ask. So they'll give Nyquist plot, for example, like this. And they'll mention that there is no pole in the right half S-plane. They'll mention open loop poles. The Nyquist plot over the frequency range 0 to infinity is shown in figure. For which no open loop pole right hand side. For which no open loop pole right hand side. Open loop pole right of S plane. Then closed loop system is, they'll ask like this. Then closed loop system is stable, unstable with one pole right, unstable with two poles right, unstable with three poles right, like that questions, like that options they'll give. Then how to draw the Nyquist plot first of all here? How to draw the Nyquist plot first of all here? We should draw the Nyquist plot now. Listen, if you listen, then only you'll get. They don't ask draw the Nyquist plot. Most of the time, they are giving the polar plot over the frequency range 0 to infinity. They are asking the question like this. Most of the time. Then first what you have to do, you have to make it Nyquist plot. First you have to draw the mirror image like this. Mirror image you have to draw. First you have to draw the mirror image like this. Then how many infinite radius semicircles you will draw? How many infinite radius semicircles you have to draw? They don't mention number of poles at origin. They don't mention number of poles at origin. They don't mention number of poles at origin. Then how to draw? Simple logic is whenever they give the polar plot, and not mention the poles at origin, simply we should join from mirror image to, this is the mirror image, na? This is mirror image. Just to join mirror image to polar plot. This is polar plot. Join mirror image to polar plot by using minimum number of infinite radius semicircle. Join mirror image to polar plot by using minimum number of infinite radius semicircle. So that means what you have to do? Don't join like this. That is not an infinite radius semicircle. Infinite points should be joined with infinite radius semicircle. Minimum number. That means here to here is 1. And here to here is 2. That's all. Minimum 2 required here. To join mirror image to polar plot, how many minimum required? 2. Only 2 you should draw. If more than 2 is there, no doubt you will mention number of poles at origin for this problem. In any question, more than default condition is there, you will mention the poles at origin. If more than default condition is what? We should join from mirror image to polar plot by using minimum number of infinite radius semicircle. Join by default. by default join mirror image to polar plot. By default, join mirror image to polar plot by using minimum number of infinite radius semicircle. Infinite radius semicircle. Just join the mirror radius semicircle. Minimum here how many? 1, 2. 2 only required, so 2 only use it. If more than 2 is there, 100% will mention number of poles at origin. Not mention means join with mirror image, join with the minimum number of infinite radius semicircle. Okay, na? Okay, okay. Come back. So now solve this. Now join it here, 2 poles. Here poles are given. Directly draw it. Just for understanding, I discussed that. Here 2 poles at origin means 2 infinite radius semicircle. Start from mirror image. Move in clockwise direction. Start from mirror image. Move in clockwise direction. Move in clockwise direction. So here to here is 1. Here to here. End at where the polar plot is started. End at where the polar. In case starting ending is same point, then we cannot identify where the infinite radius semicircle starting and ending. That's why these two are put in different lens to identify where it is starting, where it is ending. I taken different lens. So this is the infinite radius semicircle. Now check the stability. Now check the stability. How many open loop poles right? Open loop poles right, how many tell? P equal to 0. No open loop pole right. Now critical, these are infinite points. Now these are infinite points. That means 1 is inside. Now -1 should be inside. -1 should be inside. Critical point should be inside. -1 should be inside. Inside. Now draw a line and check it how many times intersecting. Draw a line and check it how many times the plot is encircled -1. So here once encircled, this is clockwise. Clockwise means -1. This is clockwise. This is clockwise only na. This is clockwise only na. This is also clockwise na. Clockwise means -1. N equal to -2, but P equal to 0. N is -2, P 0. N is not equal to P. That means closed loop system is unstable. Closed loop system is unstable. Like this you have to do. N is clockwise means negative sign, -1. Clockwise negative sign, -1. N is -2. P equal to 0. N is not equal to P. Closed loop system is unstable. Closed loop system is unstable. Okay, na? Now tell. You have to find the number of poles in the right hand side. You have to find the number of poles in the right hand side. Find the number of poles in the right. N equal to P minus Z. Number of poles in the right hand side given by number of closed loop poles in the right of S plane. Given by N equal to P minus Z. So N is how much? -2. P how much? 0. Minus Z. Z equal to how much? 2. Z is called what? Zeros of characteristic equation, which are called closed loop poles. Zeros of characteristic equation is called closed loop poles. I told very clearly. 2 closed loop poles right hand side. 2 closed loop poles right of S plane. 2 closed loop poles right of S plane. That's all. Unstable with what? 2 poles in the right of S plane. Unstable with 2 poles in the right of S plane. That's all. Okay, na? Right. Next problem. Note down next problem. Note down next problem. Right. The Nyquist plot over the frequency range over the frequency range zero to infinity. 0 to infinity is shown in figure. For which no closed loop pole in the right of S, no open loop pole. In the right of S plane. No open loop pole in the right of S plane. Then the closed loop system is draw the plot. Come on, Guruji. Come on, do it. Any doubt is there, you note down. At the end, I'll discuss it. No need to worry. After the 9 o'clock, I'll discuss the doubts. Don't worry. Page number, note down. And doubt also you write. Come on, solve and tell the answer. Option A, stable. Option B, unstable with one pole right. Unstable with two poles right. Unstable with three poles right. Come on, tell the answer. Option B. Very good. Very good. Option C, B, B. Good, good, good. B is correct, I think. Listen. First, draw the mirror image. Draw the mirror image, all of. Mirror image with respect to real axis, not imaginary. Don't fold with imaginary, with respect to real. Real means it come down. It come down. It come down. Now tell, how many infinite radius semicircle tell? They didn't mention any pole at origin. That means what default condition you have to use. What is the default condition? Join from mirror image to polar plot. With minimum number means only one is enough. Only one is enough. If it is more than one, 100% you'll mention the number of poles at origin. More than one, you'll mention the number of poles at origin. Okay, na? Now critical point is what? Inside. -1 plus j. Now draw a line. Clockwise -1. N equal to what? -1. So no open loop pole right mentioned. P equal to 0. N is not equal to P. Closed loop system is unstable. Then find number of poles right. N equal to P minus J. N is -1. P 0. Z. Z equal to what? 1. So 1 closed loop pole right. Unstable with 1 closed loop pole right. That's all. Like this you have to solve. Next problem. ठीक है ना? Next problem. The Nyquist plot. The Nyquist plot over the frequency range zero to infinity is shown in figure. For which one open loop pole in the right of S plane for which one open loop pole in the right of S plane. Then the closed loop system is draw the plot. Come on, Guruji. Come on, Bhaiya. Come on, do it. Tell the answer. Critical point -1 only left now. How can it represent in the right tail? Critical point always left on. -1 na negative real axis. Critical point means -1 plus J0 only. Unstable. Is it unstable or stable? Unstable, one pole right. Any more? Two poles right. Stable. So we'll do it. First take the mirror image. First take the mirror image like this. Right. Now how many infinite radius? Only one, because I can join mirror image to polar plot with one only. This is infinite radius. This is infinite. Means -1 is inside only. -1 inside. Draw a line. Draw a line. Draw a line. Then tell what is n value? N equal to -1. Critical, what is the direction? Clockwise, -1. P equal to what? 1. P mentioned one pole right. So that means N is not equal to P. Closed loop system unstable. Like this you have to solve. The number of poles right. Most of the time like this only they are asking. 90%. If you see any question in the Nyquist plot, they'll give a polar plot, they'll ask about closed loop. The second way is range of K values for stability. These two only they are asking. Then N equal to P minus Z. N is -1, P is 1, Z. Z equal to what? 2. 2 closed loop poles right hand side. Okay. Next problem. Unstable with 2 poles in the right half S plane. Next problem, do it. Draw the Nyquist plot and discuss the stability. 100 by S cube into S plus 1. Draw Nyquist plot and find stability. Come on, do it, bhaiya, do it. Jaldi jaldi karo. Z never be negative. You don't get negative unless until you do mistake. Z will be always positive. Come on, come on. S replaced by J omega. Hundred by omega cube root of omega square plus 1. Phase angle minus 270 minus tan inverse omega. What is the direction? Clockwise. Omega 0 infinity minus 270. Omega infinity 0 minus 360. Come on, do it. Draw na? Unstable with 2 poles, right? Very good. Right. Come on, draw it. Minus 270 start. Minus 360. What is the direction? Clockwise. Same plot you will get it for even what? Same plot you will get for 1 by S into minus S minus 1. That only I given here in this question. This question, see, same plot. This is the plot for actually 1 by S into minus S minus 1 actually. That's why I mentioned no pole in the right. Here you observe no pole in the right. No pole in the right. Even with RH criteria check, same answer you will get. With RH criteria check, same answer you will get. Okay, na? So, same polar plot will be there for the what? 2 different transfer functions. So, even if you write pi here, you will get the same minus 270 minus tan inverse omega only will get for this. Okay, but don't draw one encirclement because they're given transfer function. Means you have to take it what? 3 poles mentioned at origin means 3 encirclements you have to take. Take the mirror image. Next, how many infinite radius semicircle? 3 poles, na 3. So here, 1, 1, 2, 3. It should be ended where the polar plot started. So this is 1, 2, this is 3. Critical point is inside. 3 na s power 3 means 3 encirclements. Critical point is inside. Minus 1, because these are infinite points. This is minus 1. This is also minus 1. N equal to minus 2. P, how many open loop poles right here? Open loop poles right. Come on. P equal to 0. N is not equal to P. Closed loop system unstable. N equal to P minus J. Come on, minus 2. 0. Z equal to 2. That means 2 closed loop poles right. Two closed loop poles right. Unstable with 2 poles right. Next, conditional stable systems. We'll take the break at 7:15. What time you want break? 7 o'clock. 7 o'clock, okay? Okay, I'll give at 7 o'clock. 7 or 7:30? 7:30 will take better. Okay? Okay, most of them asking 7:30. I'll give break at 7:30. Okay. 7:30, okay. Right. Next question. Next, put the heading conditional stable. Listen, carefully listen, then you can understand. Conditional stable systems. Note down the question. Find the range of K value. Find the range of K value for closed loop system stability. To the given system. Find the range of K value for closed loop system stability by using Nyquist stability analysis. By using Nyquist stability analysis. By using Nyquist stability analysis to the given system. G of S, H of S equal to K by S plus 1, S plus 2, S plus 3. See, for this problem, already I drawn the polar plot, either remembered or not. Sir, I draw it polar plot, all of you, make it fast. Draw the polar plot, all of you. Draw the polar plot. S replaced by J omega. Intersection point, remembered, I told B remember intersection point for this problem. j omega plus 1, j omega plus 2, magnitude k by root of omega square plus 1, omega square plus 4, omega square plus 1. Phase angle minus tan inverse omega minus tan inverse omega by 2 minus tan inverse omega by 2. What is the direction? Clockwise. Omega 0, what is the magnitude? Tell. K by 6. What is the phase angle? Tell. 0 degrees. Omega 0 magnitude is K by 6. Angle is 0 degrees. Omega infinity 0. Angle is minus 270. That is right. Now draw the plot. Start at 0 degrees. Magnitude of K by 6. End at minus 270. Here 0. Join. Already I drawn this. One more thing we discussed here is intersection points we find either remembered or not. I want intersection point with minus 180. Refer polar plot for that. Or angle GH equal to minus 180. Solve by yourself. So you will get intersection point is here minus K by 60 you will get. And omega root 11 we got. Check it in the polar plots. Or find it intersection point with minus 180. Angle GH equal to minus 180. You solve it. Already we solved in the polar plot. You can check it. There I taken 1 by, here you put it numerator K. That is the only difference. There you got minus 1 by 60. Here K by 60. Now we'll discuss how to find the range of K value. We'll discuss how to find the range of K value. Okay, na? Okay? Listen. Listen. Draw the plot. Draw the polar plot. Direction. This is the plot. Now make it Nyquist. Make it Nyquist. Come on. Take the mirror image. Make the Nyquist plot. This is the Nyquist plot. Give the direction. And intersection point with minus 180 is minus k by 60. Intersection point with minus 180 is minus k by 60. Now come and do it. How to find the range of k value? Listen. First step actually not required, but still I will tell. Okay, na? First step is procedure here. Step 1 is assume the intersection point. Assume the intersection point with minus 180 degrees is equal to critical point. ठीक है ना? ठीक है? Assume the intersection point with minus 180 degrees is equal to critical point. Is equal to critical point. This is the first assumption. Or simply k by 60 equal to 1. Magnitude of intersection point equal to 1. So what we are getting tell? Assume that magnitude of intersection point equal to magnitude of critical point. Anything, both are same. For example, minus k by 60 equal to critical point means minus 1. Minus become plus. That means what happened? K by 60 equal to what? 1. First you have to assume here k by 60 equal to 1. That means at that point generally system marginal stable. That means at that point system is generally marginal stable. K equal to 60 marginal stable generally. But Nyquist never talk about the marginal stability. In the Nyquist plot, he will talk about only either stable or unstable, but not the marginal stability. He never talk about the marginal stability. So don't write any condition for the marginal stability. Okay. Next step 2. Step 2 very important. Step 2, step 3 very important. Step 2. So here k by 60. Magnitude I consider. Or okay, minus k by 60 want to take. Second step. First step is dummy, not required. Second step is more important. Assume that the magnitude of intersection point, IP means intersection point. The magnitude of intersection, here intersection point. So IP means intersection point. Be remember, assume that the magnitude of intersection point with minus 180 degrees is greater than 1. Is greater than 1. The magnitude of intersection point with minus 180 degrees is greater than 1. Is greater than 1. Greater than 1. Greater than 1. In this case, critical point is inside the loop. Critical point is inside the loop. Inside the loop. Get the number of encirclements. Number of encirclements and condition for stability. And condition for stability. So what is the second condition means? Listen. Listen, Bhaiya. What is the second condition means? So this is the diagram for second case. This is the diagram for second case for step 2. So we have to assume magnitude of k by 60. Magnitude means sign gone na. Magnitude of intersection point with minus 180 degrees and k by 60. K by 60. What we have to assume? Greater than 1. They are telling assume that magnitude greater than 1. Wherever intersecting, there you have to assume magnitude greater than 1. That means this point is greater than 1. Yeah? This point is greater than 1. What is intersection point? K by 60. Magnitude k by 60 greater than 1 they are telling. So always you have to assume whatever the point it is greater than 1 you assume. So this is 0 na. This is greater than 1 na. Greater than 1 means like 10 no. Then 1 will come automatically inside the loop na. Then 1 will come automatically inside the loop. 1 will come automatically inside the loop. 1 will come automatically inside the loop. Draw a line here. 1 means it is a critical point only, minus 1. Magnitude of minus 1 only, na? It is a critical point. 1 will come inside. 1 will come inside means minus 1 also inside. Now count the n. What is n? Tell. N equal to, this is clockwise, minus 1. This is clockwise, minus 1. N equal to minus 2. P equal to how much? 0. There is no pole in the right hand side. N is not equal to P. Closed loop system is unstable. Closed loop system unstable. Which condition it is unstable? K by 60 greater than 1 unstable. That means K greater than 60 closed loop system is unstable. K greater than 60 closed loop system unstable. Find the number of poles, right? N equal to P minus Z. N is minus 2. P is 0 minus Z. Z equal to 2. That means 2 closed loop poles right. 2 closed loop poles are right. 2 closed loop poles are right. Like this you have to find. So that means when K by 60 greater than 1, K greater than 60, the system is unstable with 2 poles right. K greater than 60, the system is unstable with 2 poles right. If you want, you can verify with RH criteria also. You can verify with RH criteria. This is for step 2. Next step 3. Next step 3, listen. Next step 3. Step 3. Step 3. Right. Assume that the magnitude of intersection point, IP means intersection point, with minus 180 degrees is less than 1. Assume that the magnitude of intersection point with minus 180 degrees is less than 1. So in this case, critical point is outside the loop. Not outside the loop means not outside the infinite. In case infinite circle is there, don't say take outside. Just outside of finite loop. Outside of finite loop. Outside the loop. In this case, critical point is outside of finite loop. Get the number of n circlements. Get the number of n circlements and condition for stability. Stability means closed loop, not open loop. Come on, and what I am telling here, you take K by 60 is less than 1. Magnitude less than 1, na? So that means k by 60 we have to. What you are telling, magnitude less than 1. That means k by 60 less than 1. Magnitude of minus k by 60 magnitude means what? K by 60, na? K by 60 less than 1. You have to assume less than 1. So that means at this point, I'll write in other side. Wait. Right. I'll write here. So k by 60 less than 1 because magnitude less than 1. At this point, magnitude is less than 1 here. At this point, magnitude is less than 1. Magnitude less than 1 here. Magnitude less than 1. Then critical point is what? Outside the loop. That means minus 1 is here. Minus 1 plus J0 is here. Outside the loop. Critical point. 1 is outside the loop now. For example, here, this is less than 1. This is 0. This is 0. This is less than 1. Means 1 is outside now. This is less 0.5, for example. This is 0.5. Means 1 is here. So you draw a line. That means minus 1 is here. 1 is here means minus 1 is here. Then find n value. What is n? 0. What is p? 0. N equal to what? P. Closed loop system what? Stable. N equal to P, closed loop system is stable. N equal to P, closed loop system is stable. Which condition tell? K by 60 less than 1. K is what? Less than 60. Closed loop system is stable. K less than 60, closed loop system stable. That's all. So automatically in step 2, step 3, one condition is going to be stable. For example, if it's step 2 itself stable, no need to check step 3. Even if you check it, it will get the unstable. So even if you check it, it is unstable. This is for step 3. Next. Okay, yeah? This is for step 3. So now we got it k less than 60 stable, you got very good. K less than 60, we got it stable. This is for diagram for step 3. This is for step 3. So k less than 60 stable you got. Then what is the lower limit? K less than 60 stable, correct. But what is the lower limit? Is it 0? Is it minus infinity? What is that limit? What is the lower limit? Anybody? What is the lower limit? Is it 0? How can you say it is 0? Is it minus infinity or minus 0 or what is the minus 6? Listen, Bhaiya. We cannot say 0. If in case there is no intersection point with the 0 degrees, then it is 0, no doubt. If there is no intersection point with 0 degrees, then I can say lower limit is 0. Then I can say lower limit is 0. Listen, step 4. Step 4. Right. Step 4. Listen. What is step 4 means? Okay, no problem. It is there. Step 4. See, whenever the stability condition is less than certain value, whenever the stability condition, whenever the stability condition is less than certain value, then the lower limit decided by, is decided by intersection point with 0 degrees. The lower limit is decided by intersection point with 0 degrees. The intersection point with 0 degrees, always greater than minus 1. Always greater than minus 1. Greater than minus 1 to become stable. To become stable. To become closed loop system stable. Why it is greater than minus 1 means, listen, all of you listen. Listen by all of you listen. Carefully listen. See, for example, we got k less than 60 stable. K less than 60 stable we got. K less than 60 means what is the lower limit? Can I take, for example, minus 12? Can I take k equal to minus 12? K equal to minus 12 is less than 60 or not? K is minus 12 is less than 60 or not? It is less than 60, no doubt. Now I'll substitute k equal to minus 12 here. If I substitute minus 12, what I am getting? Minus 12 by 6. That means this point coming to minus 2 means somewhere here. This is minus 1, na? This is minus 2. This is minus 2. Where is this? What is this point? Actually, minus k by 60 this point. Minus k by 60 this point. K equal to minus 12 substitute. Minus of minus means 12 by 60. 1 by 5, 0.2. That means it comes to 0.2 here. That means if I draw the plot, actually, see, this point is coming to minus 2. This point shifted to minus 2. This point shifted to plus 0.2. Then in case if I draw the diagram, you may get it like this, for example, just for understanding I am drawing. You may get like this. You may get like this. That means what? N is again not equal to 0. N is not going to be 0. N is not going to be 0. N is some value. It may be plus 1, minus 1. Again, system become unstable. Again, system become what? Unstable. Again, system become unstable. That means what? This point, it can come to left, nothing wrong. This point, it can come to left, nothing wrong. But it should not cross the minus. It can come up to this. But it should not cross the minus 1. It can come up to minus 0.9999. But it should not cross the what? Minus 1. That means it should not cross the minus 1 means k by 60 must be greater than minus 1. K by 60 must be greater than minus 1. K by 60 must be greater than. Okay. K by 60 must be greater than minus 1. K by 60. K by 60 must be greater than minus 1. Always blind logic. Anywhere you see an intersection point with 0 degrees, put it greater than minus 1. Why? Because that should not cross this point. If it is crosses this point, minus 1, if crosses minus 1, again encirclement occurs. Again encirclement occurs means the stability condition changes. The stability condition changes. That means k by 6 greater than minus 1. K is greater than minus 6. So total answer is what? What is the total answer? Tell. K greater than minus 6, less than 60. You want to check with RH criteria, you will get the same answer. K greater than minus 6, less than 60, closed loop system is stable. K greater than minus 6, less than 60, the closed loop system is stable. That's all. Gone. Okay. Next. But simple shortcut I'll tell, instead of doing all this nonsense things, simple shortcut. Listen. Simple shortcut. This is k by 6. Now draw the plot. Now listen, this is the plot. What is this point L? Minus k by 60. Consider magnitude. Consider magnitude means k by 60. Listen, simply what you have to do, right side make it dark. Walking, you walk along the direction, right side make it dark. This is the complete right. Complete right side make it dark. Complete right side make it dark. So this is right side. This is a shaded area. This is a shaded area. Shaded area. Now identify unshaded areas with minus 180 degrees. This is minus 180 degrees line. Range of k value limit decided by what? Minus 180 degrees generally, and another thing 0 degrees rare cases. You identify unshaded areas with minus 180. This is shaded area, na? This is shaded area. This and all shaded. This is unshaded area. In unshaded, this is unshaded area. This is unshaded. Unshaded area. Unshaded. Unshaded area. In unshaded area, we should select the 1. You should select the critical point or 1. In unshaded area, select the 1. Select the 1. Unshaded area, we should select the critical point. Critical point means magnitude of critical point is 1. So in unshaded area, always in unshaded area, you have to select the critical point, that is minus 1. Then take the magnitude for that. Take the magnitude for that. That means it is 1. Here 1 means what is this value tell? This is 0. Here 1 means this is what? Less than 1 or greater than 1? This is 0. This is 1. This should be what? What should be this tell? What should be this value? Less than 1. Because here 1 means it should be less 0. Less than 1. Here 1. So this should be less than 1. That means what you got? K by 60 less than 1. Another condition, whenever you are seeing 0 degrees intersection point, always greater than minus 1. That means this is what? K is greater than minus 6. This is what? K less than 60. So pura condition, complete condition is what? K greater than minus 6 less than 60. The system is stable. That's all. No need to check number of closed loop, n equal to p, kuch bhi nahi. No need to check even n equal to p. Even if you check it, same answer you will get. Even if you check it, same answer you will get. Like this, you can get the answer. ठीक है ना? Next problem. ठीक है? You try to solve in the break time this problem. After the break, I'll discuss. ठीक है ना? ठीक है? Find the range of k. Repeat the above problem. K into s plus 3 by. How much time break you want? 15 minutes break. How much time? $10 enough? 20 minutes? Most of them 20 minutes they are asking. You take 15 minutes. Take 15 minutes at least. Worst case below 20 minutes will start. Okay? Take 15 minutes break, all of you. You try to solve this. After the break, I'll discuss. Okay? Take 15 minutes.
Good afternoon, dear students. Myself Venkat Reddy. From Sunday onwards, I'm starting communication classes for you. I'm willing to plan from 11 o'clock, 11 to 8:30. Is it okay for you? Dear students, those who are regular batch students of 21 gate, from Sunday onwards, I am willing to start from 11 to 8:30 communication. Comfortable for the regular batch students of gate 21. And those who are college goers of 2022 and college goers of 21, for them, there will be a network class for evening 6 to 8:30. Those who are the students of gate 2022, for them, there will be networks of 6 to 8:30. Those who are students of gate 21 regular batch students, for them, there will be a class from 11 to 8:30 communication. Is it okay for you guys? And those who are students of gate 2022 and gate 21 college goers, for them, there will be class of evening 6 to 8:30 networks. Gate 2022 and gate 21 of college goers, for them, there will be 6 to 8:30 networks. For regular batches of gate 2021, it will be 11 to 8:30 communication. Is it okay for you guys? And for batch 1, batch 2, syllabus is over. Once controls is done, syllabus is over. Already additional syllabus of communication has been completed. No, few batches already completed with communication. And for instrumental and process controls. For instrumentation guys, there will be optical and process controls. Those who are already done with communication, there no need of attending communication. For batch 1, its communication is already done. Just I am asking only for gate 21 students, those who are left with communication, for them 11 to 8:30 is okay. Already additional syllabus of communication has been completed for batch 1. Kartikeya, you can write the test series. Kartikeya signals, later it will start. Instrumentation guys, from Sunday or Monday onwards, there will be optical or process controls class. All batches of regular gate 21 networks has been completed. And speaking about gate 2022 of EC and instrumentation of college goers, for them it will be 6 to 8:30 networks. Those who are giving gate 21 of regular batch students, for them it is communication 11 to 8:30. Triple E 2022, it will be networks. For GATE 2022, it will be a networks class of 6 to 8:30. EMTL will be last year for batch 5. After communication, it will be EMTL, and after that, it will be signals for GATE 21. Those who are giving GATE 21, after communication, it will be EMTL, and after that, there will be signals. Those who are students of GATE. For GATE 2022 students, for them it will be 6 to 8:30 networks. For GATE 2022, evening 6 to 8:30 networks. GATE 2022 of EC, electrical and instrumentation. For GATE 21 of batch 3, batch 4 and batch 5, 11 to 8:30 communication is okay for you guys. Communication, first it will be done. After that, it EMTL. After that, it will be a signals for GATE 21 students. That's what I'm saying here. Once communication has been completed, that next subject will be EMTL, and after that there will be signals for GATE 21 guys. And those who are students of batch 1 of college goers, for them it will be evening 6 to 8:30 networks. Just confirm me, you guys having interested to come from 11 to 8:30 communication. Just confirm me 11 o'clock is convenient to you guys for communication. 11 to 8:30 is okay for you guys. Just confirm me that. So accordingly, I'll plan your schedule.
ఓకే ఎంకరేజ్ అయిపోయిందా?
అయిపోయింది సార్. ఒకసారి అడగండి సార్.
ఏది
కమ్యూనికేషన్ 11 నుంచి ఓకేనా అడగండి సార్.
కమ్యూనికేషన్ 11 to
11 to 8:30 అంటే 21 వాళ్ళకి, 22 వాళ్ళకి నెట్వర్క్స్,
22 వాళ్ళకి నెట్వర్క్స్, 20 వాళ్ళకు కమ్యూనికేషన్స్,
21 వాళ్ళకి కమ్యూనికేషన్,
21 కమ్యూనికేషన్.
అందులో ఎవరైనా కాలేజ్ గోయర్స్ 21 వాళ్ళు ఉంటే వాళ్ళకి నెట్వర్క్స్ చెప్పండి.
21 కాలేజ్ గోయర్స్ అండ్
వాళ్ళకి నెట్వర్క్స్,
21 కాలేజ్ గోయర్స్ అండ్ 22
కాలేజ్ గోయర్స్ నెట్వర్క్స్,
22 కాలేజ్ గోయర్స్, 21 కాలేజ్ గోయర్స్ కు నెట్వర్క్స్, 21 వాళ్ళకు కమ్యూనికేషన్స్,
21 వాళ్ళకి
11 to
8:30 communication.
8:30 communication. So if you have any problem, you can talk. 21 GATE 21 communications 11 to 8:30. If you have any doubt, you can talk. Run 21, 22 college goers networks. Timing networks?
Evening 6 to 8:30, sir.
Evening 6 to 8:30. Okay. Networks was completed.
కాలేజ్ గోయర్స్ కి అయిపోయింది సార్. అంటే కాలేజ్ రెగ్యులర్ బ్యాచెస్ కి అయిపోయింది సార్ నెట్వర్క్స్.
Not regular batch students. I am talking about college goers. Don't respond. Regular batch students.
తర్వాత ఇన్స్ట్రుమెంటేషన్ వాళ్ళకి ఆప్టికల్ అండ్ ప్రాసెస్ కంట్రోల్ చెప్పండి సార్.
Instrumentation. In this instrumentation, లేనట్టున్నారు కదా వెంకరెడ్డి.
ఉన్నారు సార్.
Instrumentation, optical
ప్రాసెస్ కంట్రోల్స్
and process control.
గేట్ 21 వాళ్ళకి.
Gate 21 వాళ్ళకు.
22 వాళ్ళకైతే నెట్వర్క్స్.
22 network. Instrumentation, gate 22 networks.
Hmm.
Gate 21 instrumentation, optical and process control. Okay.
రైట్ సార్.
Okay. Timing optical and integrity timing.
నేను అప్డేట్ చేస్తాను సార్.
You will update in the web. Okay. Right. Solve this problem. Come on. Solve it. Solve this problem. Right. Do it. So what happened? S replaced by j omega. GH of j omega equal to k into j omega plus 3 divided by j omega into j omega minus 1. Now magnitude k into root of omega square plus 9 by omega into root of omega square plus 1. Phase angle minus 90 minus of, this is second quadrant na, j omega minus 1 means negative real and positive imaginary, second quadrant. So 180 minus tan inverse omega, second quadrant, plus tan inverse of omega by 3, plus tan inverse of omega by 3, minus 270 plus tan inverse omega plus tan inverse omega by 3 plus tan inverse omega by 3. What is the direction? Tell. Anti-clockwise. The direction is anti-clockwise. Anti-clockwise. Now omega 0, magnitude infinity, phase angle minus 270. Omega infinity, magnitude 0, angle is minus 90. So satisfied condition. Now draw the plot. Which direction you have to draw? Anti-clockwise. Now draw the plot. Where it starts? Minus 270. This is minus 270. Where it ends? Minus 90. This is minus 90. What is the direction? Anti-clockwise. So the direction is anti-clockwise. Means like this. Like this. Anti-clockwise, na? This is the anti-clockwise. This is anti-clockwise. This is anti-clockwise. Anti-clockwise. So next, fold with respect to real axis. Fold it. First, you find the intersection point with minus 180. You find intersect here omega 0. Here omega infinity. This is minus 180. I want this intersection point. Find intersection point with minus 180. Find the intersection point with minus 180. So intersection point with minus 180. Intersection point with minus 180. Angle GH equal to minus 180. So minus 180 equal to minus 270 plus tan inverse omega plus tan inverse omega by 3 plus tan inverse omega by 3. Now what happened? If you come this side, 90 equal to tan inverse of omega plus tan inverse of omega by 3. Now solve this. Tan inverse A plus tan inverse B. 90 equal to tan inverse of A plus B by 1 minus AB. 1 minus omega square by 3. Omega square by 3. Tan 90 infinity. Infinity means denominator is 0. Infinity means denominator 0. Denominator 0 means 1 minus omega square by 3 equal to 0. Then find omega, that is root 3 radians per second. Here omega is root 3. But intersection point is not omega radians per second. Intersection point is called magnitude. So magnitude at omega root 3 equal to k into root of k into root 3 substitute. Omega square means 3. 3 plus 9 by root 3. 3 plus 1. So that means k root 12 by root 12. K root 12 by root 12. K into root 12 by root 12. Both cancel. What is the answer? K. That means at this point magnitude is k. At this point magnitude is k. Now draw the Nyquist plot and find the range of k value for stability. Draw the Nyquist plot. Anybody solved? Root 3 correct k. So draw the Nyquist plot. Find the range of k value for stability. Come on, do it. Come on. Draw the one more time plot. This is the plot. Direction. Right. Take the mirror image. Take the mirror image. Next, infinite radius semicircle. One pole at origin, one infinite radius semicircle. One pole at origin exists. This is called omega. Omega not required. Magnitude k here. That's all. Now do it. Now tell the answer. When it is stable. Once assume greater than 1, once assume less than 1. That's all. Forget about first step. Assume k greater than 1 once. Next, assume k less than 1 once. And tell the answer. Assume k greater than 1 once. K less than 1 once. Come on. Zero at origin already I told now you have to go by standard procedure. No encirclement for zero at origin. Come on. K greater than 1. We can do with RH, same answer we will get. But in the exam, they don't give transfer function. They'll give this plot. Here they'll put it K. Then what you will do? If you give transfer function, go by RH. No problem. Okay. Now I will assume this is greater than 1. That means this point is greater than 1. If this point greater than 1, 1 is inside. Draw a line. Now tell this is anti-clockwise plus 1. This is anti-clockwise plus 1. This is clockwise minus 1. Anti-clockwise plus 1, anti-clockwise plus 1. This is clockwise minus 1. N equal to what? Plus 2 minus 1. Become what? Plus 1. How many open loop holes right? Tell. How many open loop holes right? Check it. Open loop holes right. One open loop hole right. Open loop holes right. P equal to 1. Now here P equal to 1. N equal to 1. P equal to 1. N equal to P. Closed loop distance stable. That's all. Closed loop distance stable. What is the condition? Tell K greater than 1. Closed loop distance stable. That's all. Closed loop distance stable for K greater than 1. No need to check to what? Check the K less than 1. No sir, I'll check. Means you check it. Nothing wrong. In case here assumed K less than 1. In case here assumed K less than 1. 1 is outside here. If I draw it, N will become what? Minus 1. Because clockwise minus 1. P is plus 1. Then what happens? System is unstable. N is not equal to P. System is unstable. System is unstable. That's all. System is unstable. Even we can solve in other way also. How can you solve? Means here we don't assume anything. We don't assume anything. How many regions are there here? 2 regions. 2 regions are there. One region is this. This is the one region. Here to here one region. Here to here another region. This is infinite point. In this region N equal to P stable. So that means in this region stable. Here N equal to minus 1. P equal to what? 1. N is not equal to P. Closed loop system what? Unstable. Unstable. That means what is the region? Here unstable means this point is wrong. We don't want critical point here because here unstable. Here unstable. We don't want critical point. Here stable. Stable means we want here critical point. Critical point means minus 1. That means magnitude of critical point is 1. That means here 1 means this should be what? Greater than 1. Here 0. Here 1 means here 2. That means this should be what? Greater than 1. This should be greater than 1. So K greater than 1. System is stable. K greater than 1. System is stable. Like this also we can solve. A simple shortcut means shortcut. So this is the point of minus K. This is the point of minus K, na? What is this point? Minus K. Minus K. Consider magnitude. Right side, shade it. Right side you shade. Shade the right side. So right side, walking direction. Like this you are walking, means this is the right, na? This is the walking direction, means this is the right. Right side, shade it. Right side, shade. This is the right. Shade it. So that means this total area is shaded. Unshaded area is here. In unshaded area, we have to select the one. Unshaded area, we have to select one. So that means here is 1. Here is 1. Here 1 means this point is what? Greater than 1. Here 1 means this should be greater than 1. Here 1 means this point should be greater than 1. That means K should be magnitude of minus K and K should be greater than 1. Closed loop distance stable. That's all. Like this simple shortcut. Next problem. Okay. Right. Next problem. GH of this is asked once in the exam. Come on, range of K value K into S plus 2 divided by S plus 1, S minus 1. K into S plus 2 divided by S plus 1 into S minus 1. Come on, Guruji. Completed. So S replaced by j omega. GH of j omega equal to K into j omega plus 2 divided by j omega plus 1, j omega minus 1. Magnitude K into root of omega square plus 1. Denominator omega square plus 1. Now write the phase angle. What is the phase? Minus tan inverse omega. Minus of 180 minus tan inverse omega. Plus tan inverse omega by 2. Then what happened? Minus 180. This minus plus getting cancelled. Plus tan inverse omega by 2. Direction anti-clockwise. Omega 0. Magnitude what? 2K. Angle minus 180. Omega infinity 0. Angle is minus 90. Satisfied our condition. Come on, draw the plot. Draw the plot. Where it starts minus 180. Where it ends minus 90. Here magnitude 2K. Here magnitude 2K. So it end at what? Minus 90. End at minus 90. Move close to minus 90 and 0. So magnitude 0. Omega infinity. Now fold with respect to real axis. Then this will become Nyquist plot. Now find the stability. Two regions are there. So one region is here, one region is here. In this region what? N equal to 0. P equal to what? How many open loop poles right? Open loop poles right. P equal to 1. That means P equal to 1. N is not equal to P. Closed loop system unstable. That's all. That means this is wrong. We don't want this point. Now I'll select this point. Here I'll select. Here I'll select. So what is this? Anti-clockwise plus 1. N equal to plus 1. P also 1. N equal to P. Closed loop system stable. So that means I want 1 here. Stable means 1 I want. That means critical point inside. That means here 1 I want. Here 0 na? Here 0. Here 1 means here should be what? Greater than 1 or less than 1? Here 1 means here should be greater than 1. Greater than 1. That means, so what happened? 2K greater than 1. 2K greater than 1. K is greater than 1 by 2. Closed loop system stable. That's all. Here you want it. You can find even how many poles right here also you can find. N equal to what? P minus Z. N equal to P minus Z. Number of poles right you want, n equal to p minus z. N 0, p 1, z equal to what? 1. So that means one closed loop pole right. Like this. In this condition, in case if you select, here 2k less than 1, k less than 0.5 if you select, k less than 1/2 if you select, system is unstable and one closed loop pole in the right side. K greater than 1 if you select, 2k greater than 1 is select, closed loop system is stable. We can verify with the simple shortcut also. We can verify with simple shortcut. So simple shortcut means what you have to do? So simply start here, this is 2k. Direction. Right side shade it. When you are walking here, this is the right. Shade the complete right. Complete right shade it. So this is the unshaded area. In unshaded area, we have to select the 1. That means here should be 1. Here 1 means what is this point? Here 1 means what is this point? Greater than 1. So 2k greater than 1. K greater than 1/2. So closed loop distance stable. K greater than 1/2. Closed loop distance stable. Closed loop distance stable. That's all. Next, one more problem is solve it. Come on. Next problem. G of s, h of s equal to k into s minus 2 by s plus 2. K into s minus 2 by s plus 2. Come on, do it. K greater than 0.5 means lower limit how will get? K greater, less means lower limit you will get, greater means how will get? When you are getting k less than certain value, lower limit you will get. Greater means what happen, man? Up to infinity, 0.5 to infinity, lower limit how will get? Right. So what is the magnitude here? 1, I think. It is just like all pass filter. Magnitude is k. Magnitude k. Write the phase. Phi equal to what? 180 minus tan inverse of omega by 2. Again, this is minus tan inverse of omega by 2. So pi equal to 180 minus 2 tan inverse of omega by 2. Direction clockwise. Omega 0 k, angle of 180. Omega infinity k, angle of 0. Satisfied condition. Now draw the plot. Come on. Draw the plot where it starts 180 degrees. So this is 180 degrees. What is the magnitude k? Where it ends 0 degrees. What is the magnitude k? Then the direction is what? Clockwise. This is clockwise. The direction is clockwise. Here k. Everywhere magnitude k only. Then mirror image you do it. This is the mirror image. This is the mirror image. Now come on, get the answer. So get the answer. For example, if I take a point here, what is n? 0. What is p? 0. N equal to p. system stable, closed loop system stable. So which condition it is stable? So here if you select here, in case here you select, in case here you select, n is what? -1. N is -1. But P0 means unstable. Unstable means we don't want this. We want this means here we want 1. Here 1 means -1 is outside. So here 1 means what is this point tell? Less than 1. Here 1 means this point should be less than 1. So that means K less than 1, closed loop system stable. K less than 1, closed loop system stable. When it is less, the intersection point with 0 degrees must be greater than -1. When it is less, the intersection point with 0 degrees must be greater than -1. The intersection point with 0 degrees must be greater than -1. Greater than -1. Then what is the total condition tell? K greater than -1, less than 1, the system is stable. The closed loop system stable. That's all. The intersection point with 0 degrees always must be what? Greater than -1. Okay, na? This is shortcut. SC means shortcut for previous problem. For this problem, you want shortcut. So for example, simple shortcut means so here it is K. Here also it is K. Walking like this. Then right side. This is right. 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 So this is the complete right. Now tell. So unshaded area. This is unshaded area. In unshaded area, we have to consider 1. So that means here 1. Here 1 means what is this point? Here 0 na. This is 0 and this is 1 means this point should be what? Less than 1. And intersection point 0 degrees always greater than -1. That means what is the answer? K greater than -1, less than 1, closed loop system is stable. Closed loop system stable. That's all. Next problem. Write it. The Nyquist plot. The Nyquist plot over the frequency range. Over the frequency range. Zero to infinity is shown in figure. Is shown in figure for K equal to 1. Shown in figure for K equal to 1. For which no open loophole. No open loophole in the right of the S-plane. In the right of S-plane. The range of K value for closed loop stability is come on, draw the plot. Draw this. Come on, anybody answer? I told it if a K not included, we should include the K. I told, remember, polar plots. I told. Completed this? Listen. I'll do the solution here. Right, direction. Right. So here, this is the point given what? Minus 0.2. This is the point given what? Minus 2. This is the point given what? Minus 8, I think. Minus 8, minus 8. Now, this is the plot for K equal to 1. K equal to 1 is mentioned. No pole right side also mentioned. P is 0 also given. P equal to 0 given. Simple logic, go by shortcut. First, what you have to do, you have to include the K. That means this intersection point, product with K, 0.2 into K, divided by given K value. What is the given K value? 1. Then write the magnitude. What is the magnitude? Tell 0.2 K. Similarly here, minus 2 into K by 1. And then consider the magnitude. That means what? Minus 2K. Similarly this, minus 8 product with K divided by 1. That means this will become what? Minus 8K. Minus 8K. That's all. So now, magnitude means sign is eliminated. Na? So sign is eliminated. So 2K, 8K. 8K. So 0.2K, 2K, 8K. Now shade the right side area. When you are walking here, this is the right. 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 So right side area shaded. Gone. Now unshaded areas with 180 degrees you observe. This is minus 180 degrees. Unshaded area. Come on. Where are the unshaded area? Come on, Bhaiya. This is one unshaded area. This is one. I'll take this is the 0.1. This is 0.1. I'll take first region. This is the first region. This is unshaded area, year to year unshaded. And year to infinity also unshaded. This is second region. Two regions are unshaded. Two regions are unshaded. This is region 1. This is region 2. So I want year 1. Unshaded area we want 1. Na? So year 1. I want 1 year. 1 year means what is this point tell? Less than 1. What is this point tell? This is 1 means this should be what? Less than 1. This should be what? Greater than 1. Yes or no? Here 0, less than 1, 1 no, greater than 1. So that means what you are getting tell? For first region what you are getting? 0.2K. Here less than 1. No? This should be less than 1. This should be what? Greater than 1. That means 0.2K less than 1. And 2K greater than 1. 2K greater than 1. So K is what? 5. 1 by 2 means 5. And here k is what? Greater than 1 by 2 means 0.5. Then what is k tell? Greater than 0.5, less than 5. The system is stable. K is greater than 0.5, less than 5. The closed loop system is stable. You select any value between 0.5 to 5, automatically critical point will come only. Automatically this one will be placed in between this row, this region only. For example, 0.5 to 5. I take K1 for example. K1 is middle region. If you take K1, this will become 0.2. This will become 2. That means 1 is in the region only. 0.2, 2. 1 is in the middle region. So in this region, critical point automatically placed in the what? In the region number 1. This is for first region. Same thing you have to repeat for the second region. So don't think that here taken 1, you should not take here 1. So 1000 regions are there, 1000 regions you have to take it 1 only. So for example, in this region, I'll take here 1. I want here 1. I want here 1. Here 1 means this is the point what tell. Here 1 means here should be what? Less than 1. Here 1 means this should be less than 1. That means what? 8k less than 1. So k is what? Less than 1 by 8. You take any value k less than 1 by 8, automatically 1 will be placed here. For example, k less than 1 by 8 means I can take k equal to 1 by 10 means 0.1. If I select 0.1 here, 8 into 0.1 become 0.8 means 1 is comes to what? Outside. That means the answer is what? K less than 1 by 8 or k greater than either this or that. Not both, this or that. Either select k less than 1 by 8 or k select 0.5 to 5. The closed loop system is stable. Closed loop system stable. The system may be operated here or may be operated here. So we can operate in any of these two regions. The system is going to be stable. That's all. Last problem in range of k values. Right. One more problem. The Nyquist plot over the frequency range problem. The Nyquist plot over the frequency range zero to infinity is shown in figure, for which one open loop pole in the right half S plane the range of k value for system stability is Come on, do it. Tell the answer. Come on. Answer. Come on, Guruji. Come on. Right side, shade it. Or I'll draw the mirror image and then solve it. You solve it. Then also okay. Same answer you will get. When you take mirror image also same answer. How many shaded areas? How many unshaded areas? Come on, walk. For example, you are walking here. You are walking here. Then this is the right. 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 If you are walking here means this total is right. This total right. 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 This total right. 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 That's all. Now, how many unshaded areas? Tell. Number of unshaded areas. Anybody? How many? 3 ना. 3 unshaded. क्या भैया? देखो एक बार. 2 only. This is shaded na. When you are walking here, this total gone. This total gone. Previous case, if you take in this case, it is bounded by this. When you are walking here, it is bounded by this region. It is bounded by this region. But in this case, what happened? There is no bounded. So when you are walking here, this total right's gone. Or even if you take critical point here, what is n value? Yeah? 0. But P is 1, unstable. P unstable. You take here, n is plus 1, P is 1, stable. You take here, n is 1, P equal to 1, stable. When you are walking here, this region gone. 2 regions only. Come on, get the answer. This is region 1. This is region 2. Come on. Here we want it 1, for example. Here we want it 1. Here 1 means what? This is what? This is what? Less than 1. This is what? Greater than 1. That means 0.2 K. Less than 1. K greater than 1. So for region 1, 0.2 K less than 1 and K greater than 1. K less than 1 by 0.2 means 5 and K greater than 1. K is greater than 1 less than 5. K greater than 1 less than 5. Next for second region, we assume here 1. Here 1 means this should be less than 1. This should be greater than 1. Greater than 1. Then what happened? 2K less than 1. 5K greater than 1. Then below second region. 2K less than 1. And 5K greater than 1. K less than 0.5. And K greater than 0.2. The answer is greater than 0.2, less than 0.5. So what is the final answer? K greater than 1, less than 5, or K greater than 0.2, less than 0.5. For this region, closed loop system is stable. That's all. Okay. Right. Very good. Next, put the heading calculations of gain margin and phase margin. Calculations of gain margin and phase margin. Calculations of gain margin and phase margin. Now note on the problem. Calculate the gain margin. Calculate the gain margin for G of S, H of S equal to 1 by S into S plus 1, S plus 2. Come on. First, what is the formula for gain margin? Gain margin equal to 1 by magnitude of G of J omega, H of J omega at omega equal to omega PC in linear. In dB means minus 20 log of magnitude of GH of J omega at omega equal to omega PC. Step 1, find omega PC by using angle GH of J omega equal to minus 180. Step 2, find magnitude at omega PC. Step 3, find gain margin. Come on. Find gain margin. Come on, Guruji. Come on, do it. First, find omega PC. Omega PC. Angle of GH of J omega equal to minus 180. Bolo, minus 180 equal to minus 90 minus tan inverse omega minus tan inverse of omega by 2. All minus become plus. Then 90 equal to tan inverse of omega plus tan inverse of omega by 2. Then 90 equal to tan inverse of omega plus omega by 2 divided by 1 minus omega square by 2. Tan 90 becomes what? Tan 90, if you go this side, becomes infinity. Infinity means denominator 0. Denominator 0. That means 1 minus omega square by 2 equal to 0. What is omega? That is called omega PC. How much? Root 2 radians per second. Omega PC is root 2 radians per second. Then find the magnitude at omega PC. Magnitude at omega PC. That is root 2. What is the magnitude? 1 by omega root of omega square plus 1. Omega square plus 4. 1 by root 2, root 3, root 6. 1 by 6. Next, find gain margin. Gain margin equal to 1 by magnitude at omega PC. That means 1 by 6. That equal to 6 in linear. Greater than 1 means stable. 6 in linear means greater than 1. Na? I can say closed loop gesture stable. If you want in dB, gain margin in dB. So minus 20 log of magnitude at omega PC. What is the magnitude at omega PC? 1 by 6. You solve it. Plus 15.56 dB. So positive. Positive means stable. That's all. See here, up to second order system, up to second order system of minimum phase, especially gain margin, phase margin calculated to only minimum phase systems. Up to second order system, the gain margin is infinity. If this is very important, be remember. Why? Because up to second order minimum phase system 100% stable. So gain margin infinity should not calculate at all. If order of minimum phase system, if order of minimum phase system, MPS and minimum phase, minimum phase system, some people they'll forget minimum phase system, order of minimum phase system. If order of minimum phase system is less than or equal to 2, then gain margin is infinity. Then gain margin equal to infinity because it is absolutely stable system. Omega PC does not exist. Omega PC, second order we can say infinity. Omega PC does not exist. Does not exist. Exist for first order. Omega PC does not exist. It is for first order. First order system. Second order infinity. Omega PC equal to approximately infinity for second order. Y means, listen, one pole gives the maximum angle of how much? Tell. Minus 90. Two poles minus 180. That means omega PC is what? Minus 180 degrees. Minus 180 possible only when there are two poles, means order should be minimum 2. Then only omega PC become infinity, gain margin infinity. Whatever it is, up to second order system, the gain margin blindly infinity. First order means what happened? For example, 1 by s plus 1 I'll take. What is the Bodo plot? 1 by s plus 1 means corner frequency 1. The slope is minus 20. That's all. What is the phase plot? Tell 0 and minus 90. That means we are not having minus 180 degrees at all. It is a first order system. Minus 180 not there. That means omega PC does not exist. That only I written here. Omega PC does not exist. If I take a second order system, you'll get minus 180. If in case I'll take second order system, GH equal to 1 by S plus 1, S plus 2 in case I consider. So what happen if I draw the plot? First corner frequency 1, second corner frequency 2, 0, minus 20, minus 40, minus 20, minus 40. If I draw the phase plot, 0, minus 90, minus 180. That means what happened? We are getting minus 180 here. So here minus 180, we should consider largest value, that is infinity. So omega p is infinity. At infinity, magnitude goes minus infinity. That's why gain margin become infinity. Be remember, for first and second order system, gain margin infinity and omega p is infinity for second order. First order does not exist. Be remember this. Third order means the angle goes to more than minus 180. Automatically you will get the finite value. For third order onwards, you will get the automatically finite value of gain margin, finite value of phase margin you will get. Okay. So write that also. If the order of the system right. If order of minimum pay system, order of MPS means minimum pay system, greater than 3, then gain margin equal to K marginal by K desired value. K marginal by K desired value. K marginal value by K desired value. K desired value means how many times gain is increased. K desired they'll mention in the question. So, and omega PC equal to omega n. Omega PC equal to omega n radians per second. Omega PC is nothing but natural frequency of oscillations. Omega PC is nothing but natural frequency of oscillations. So if K desired is not mentioned, if K desired value is not mentioned, then K desired equal to 1. Then K desired equal to 1. That's all. That means in this case, gain margin equal to K marginal value, K marginal, and omega PC equal to omega n. Omega PC equal to omega n. So be remember this. Be remember this. So for example, see, I'll go by RH criteria, method 2. So K marginal value I'll find. What is GH tell? GH of S equal to what? 1 by S into S plus 1 into S plus 2. So K marginal value how to find means that GH should consist the what? K marginal value we should get means GH value, GH should be consist K. That means numerator product with K. Numerator product with K always. You want to go by RH criteria, numerator product with K. Numerator product with K. That means what is GH tell? GH of S equal to K by S into S plus 1 into S plus 2. So numerator product with K. That means GH equal to K by S into S plus 1 into S plus 2. Okay, now write characteristic equation tell RH criteria. RH criteria. Characteristic equation 1 plus GH0. And now tell what is the characteristic equation? S key plus 3S square plus 2S plus K equal to 0. Internal product 6. External product is K. That means what happened? Gain margin equal to K marginal. K marginal. That equal to how much? 6. But this is in linear. In dB you want just apply 20 log 6. Linear means just apply 20 log, that's all. gain margin in dB. Whatever the gain margin you got it in linear, to that apply 20 log. So 20 log 6, simply 20 log 6. That equal to what? 15.56 dB plus 15.56 dB. That's all. Next, frequency of oscillation is called omega PC. How to find frequency of oscillation? Even power of s term 0 or root of s power 1 ante root 2. Even power of s terms 0. Even power of s terms 0. Even power of s terms equal to 0. Even power of s terms equal to 0. Now write. So what are even power of s term? 3s square plus k, 6 equal to 0. 3 2 ja. So that means s square plus 2 equal to 0. S equal to what? Plus or minus j root 2. So frequency omega PC equal to omega n, that equal to root 2 radians per second. This is a simple shortcut. But order should be more than or equal to 3. Order should be more than or equal to 3. If order is less than or equal to 2, blindly write infinity. Why? Because if I consider here first order system, if we draw the root locus, tell one pole at -1. So root locus is this, k equal to 0. This is root locus diagram. Angle of asymptote becomes infinity minus 180 degrees to infinity. This is root locus. That means for all the values of k greater than or equal to 0, what? Closed loop just stable. That means gain margin infinity. Whenever root locus branches, whenever root locus diagram not intersect the imaginary axis, gain margin is infinity. Even if it takes second order also, it won't intersect the imaginary axis. Why? Because one pole at -2, one pole at -1. Here root locus branch exists. This is the root locus diagram. Like this, you will get along 90, along 270. So that means what? For all the values of k, for all the values of k greater than 0, system stable. That means what happened? So gain margin is infinity. Whenever root locus diagram not intersect imaginary axis, the gain margin is infinity. RLD not intersecting imaginary, RLD root locus diagram is not crossing imaginary, not crossing imaginary axis, imaginary axis, not right side, imaginary axis. Then gain margin is infinity. Then gain margin is infinity. That means root locus branch should lies only left. Root locus branches should lies only left. Root locus branches should lies only left, not right side. Right side means unstable. Root locus branches lies should be left only. And it is a minimum phase system you have to consider, na? Right side should not consider. Root locus branches lies should lies in the left of S plane. Root locus branches lies in the left of S plane. So be remember, RLD not intersecting imaginary axis, not crossing imaginary axis means gain margin is infinity. That's all. This is the simple shortcut. Okay. Next one problem. For the root locus diagram shown in figure, the gain margin for k desired equal to 10 is Come on, do it. What is the gain margin? One. Gain margin 1. 10. Yes. 10, 10. Right. So gain margin equal to K marginal by K desired. K marginal is 100. Here K marginal 100. K desired 10. So 10 in linear. In dB means 20 log 10 plus 20 dB. That's all. Sorry. Today I will close here. Next we have to go for calculations of phase margin. Okay. Calculations of phase margin. Again, some more problems. It takes another half an hour. I think more than half an hour it takes. Takes more than half an hour. Next class we'll discuss better. Okay. So if you have any doubt, you can ask. You can write the answer. Sri Charan, tell.
Sir, 26 steps.
Tell.
Sir, here if 0.2K less than 1, then 1 will not include, no, sir.
1 is here, na, in the middle region, na.
Yes, sir, if it is less than 1,
Here 1
it
means
will,
here less than 1. Tell.
then 1 will be not included, no, sir.
Not included means what, man? Where not included?
Means n equals 0, no, sir, then.
You draw a line here. What is n?
Yes, sir, if 0.2K less than 1, it will be 1.
What is the answer?
Then it will be,
Point here less. This total range you have to observe 1 to 5. Don't see this. You observe this.
okay.
You observe this. 1 to 5 you take. 1 will
Okay,
come
sir,
middle
okay,
or
sir.
not. You check it.
Okay, sir. Okay. I thought like, okay, sir, got it, sir. Thank you.
Right. Next. Karthik.
Hello, sir.
Tell.
Sir, for the same problem, does it depends on p value,
P na. Where is P?
number of holes on
Automatically it will be
open loop
satisfied.
hole?
It is automatically satisfied, man.
Uh,
It is satisfied
Sir, if p
automatically.
is 0, then after if p is equal to 0, then after
P equal to
10K
0, how
also
can
we
you
have to
give, man?
consider, right?
If P 0 means what happened? This plot is wrong. P equal to 0 means
Okay.
this plot itself
Then,
wrong.
Okay, the plot depends on p then.
Which one?
Okay, sir.
Which one, man? Here you draw
Yes,
it,
sir,
N equal
got
to
it.
P here. You check like this. Come on, here what? Draw the Nyquist plot. Now tell, come on. Check the direction. Come on. Now tell here N0, P0, unstable. Here
Yes,
what
sir.
is N value? -1, unstable. What is N value? +1, stable. Here N value -1, unstable. Here N value +1. Yes or no? Yes or no?
Yes, sir.
Well then,
Yes, sir.
by default it is satisfied.
Okay, sir.
Okay, na? Next. Amulya.
Good evening, sir.
Good evening.
Sir,
Cheppamma.
I'm a bit confused. Can you go to 21 page, sir?
Tell.
Sir, I'm a bit confused whether to draw the half circle in clockwise or anti-clockwise, sir.
Always clockwise only. Why you want to draw anti-clockwise?
Okay.
Always clockwise only draw it. Mirror
Okay,
image
sir.
ending point start, move in clockwise.
Okay, sir. And one more, sir, in page 20 in 18F, sir. Sir, can you just repeat the point why you said that k by 6 should be
See here,
greater
greater than 1 means it crosses -1. Na? If it is less than 1 means it goes to -2.
Yes, sir.
-2 means -1 enclosed. Na?
Okay, yes, sir.
Again, it will become unstable. This point can come up to this means what is the condition? Tell.
It must be
Greater than -1.
Okay. Okay,
Yeah.
sir. Okay, sir.
Next, Jivika.
Hello.
Tell.
So page number 12.
Tell.
Sir, in this, so page number 12F, 1, 2.
1, 2 only this is.
Yes, sir. So in this, we know when a polar plot start from 270 degree, then we know that there are 3 poles at the origin.
Wrong. I told very clearly. This is the plot for 1 by s into -s -1 also.
Okay, sir.
Don't
Okay.
think that start at -270 means 3 poles. No. If it really it is for 3 poles, you will mention. The plot exists 3 poles at origin, you will mention.
Okay.
Not mention means default condition you have to use.
Okay, thank you.
Okay. Next, Akans.
Hello.
Tell.
Sir, in this page only, when you were telling 1 by s into s minus 1 means how you did it directly like that?
Directly because I know I take, otherwise you cannot.
What?
That is, you have to go from option only. In case this polar plot, if you ask, if they ask what is the transfer function, they'll give 4 options. Na?
Yes, sir.
Verify. Just option A. Starting angle, ending angle. Starting should be -270, ending should be -360.
Yes, sir. Yes.
Which transfer function satisfies? That is the answer.
Okay. And sir, in 14F. Sir, if here only like one pole was there on the origin, then only half
One
semi-circle.
encirclement. That's all.
One half. Okay, sir. Thank you, sir.
Abdul.
సరే ఇందాక అది శ్రీచరణ్ ఒక ప్రాబ్లం చెప్పారు కదా సార్ ఇందాక ఒక అబ్బాయి కార్తిక్ ఈ ప్రాబ్లం 21 అనుకుంటా
నువ్వు అట్లా చదివితే నాకేం తెలుస్తా యు టెల్ ద పేజ్ నెంబర్ విచ్ క్వశ్చన్
ఇది సార్ 2k 1 less than 2 k less than 5 ఆ ప్రాబ్లం రేంజ్
యు షుడ్ రిమెంబర్ ద పేజ్ నెంబర్
ఓకే సార్ నెక్స్ట్ ఇదే సార్ 26
టెల్
సార్ ఇది మనం ఇక్కడ p వాల్యూ ఎలా తీసుకుంటాం సార్ అంటే పాజిటివ్ నెగటివ్
గివెన్ హియర్ మెన్షన్ నా వన్ పోల్ రైట్
ఓకే వన్ పోల్ రైట్ అంటే పాజిటివ్
దట్స్ ఆల్ ఓకేనా
ఇప్పుడు క్వశ్చన్ లో మెన్షన్ చేయకపోతే మనం
100% they'll mention.
ఓకే
Okay.
ఓకే